And hi, everybody. As Will said, I'm a data engineer at FIFA, and I'm part of FIFA's performance analysis and insights team. And I'm going to talk about FIFA's data enrichment strategy a little bit today. So yeah, welcome. So before I start off talking about the strategy itself, a little bit background about our team. So our team was brought together in 2020 with the goal or with the mission to find metrics that matter and have an impact on the game or on the outcome of the game. And my role specifically was or is to define a data structure that makes this possible, kind of. So just wanted to bring you back a little bit to the issues that an organization like FIFA was or is facing, and other organizations might face the same issue. So here you see a few of the tournaments, past tournaments from FIFA, and you see that for these different tournaments, FIFA worked together with various different data providers, right? So of course, all these different data providers then all have their different event data sets or data sets, and all these data sets have different schemas. So they have different types and different terminologies. And you wouldn't be able to kind of like mix the data or compare it, right? So a common solution here is to kind of create a middle layer where you then transform all the data into a uniform schema so that you can merge it together. That is pretty helpful, but there's a core issue still remaining because these data providers potentially might have used different sets of definitions to generate the data, right? So a cross for data provider A might be completely different than how data provider B sees it, right? So again, that would render your data kind of like inconsistent because you wouldn't be able to compare, like in the example of FIFA, different tournaments with each other. So in order to solve that, really, you would need to have a uniform or standardized language that is used over all your tournaments or all your competitions to generate the data. And that's exactly what FIFA did, because we like standardization. And yeah, so introducing the FIFA football language. So the FIFA football language was developed for 2 years, and it was published in 2021. And FIFA really made a big effort here to bring experts from the various different areas of the game on and off the pitch with the goal to kind of like define a standardized terminology that precisely describes the game how we see it, and all the events around it are like precisely described. It also introduces an unseen depth of data. For example, you will see a lot of off-the-ball events, and there's a lot more going on for our goalkeepers as well. And yeah, all the documentation around the FIFA football language is available on FIFA's Training Center platform. I will share a link to this at the end of my presentation. So there we are. We now have event data. And as I mentioned in the beginning, we want to find impactful metrics, right? So of course, event data, like all of you guys know, you can take it, it's like logs of the game kinda, so you can group it by player or team or something, and then aggregate it, just do some counts, right? So as you all know, though, that doesn't necessarily translate into impact, right? Just because player one in this example has the most passes doesn't mean that he created the highest value or like his passes were his or her passes were pretty impactful. So we don't really know a lot about these passes as well. We don't know if there were, for example, forwards passes or backwards passes, and we also don't know if there were any lines broken, for example. So as you all know, we would need to introduce some more context to understand the value of these passes. And that's kind of like what I want to show you guys today, how FIFA exactly does that. So the first level of detail that we try to look at is sequencing. So we, very basic, we just try to understand what happens before and after each event. And we explicitly calculate that and make it available on our data set. So we have two types of sequences. The first one is player possession sequences, and the other one is team possession sequences. Again, it's pretty common. So a player possession sequence starts really with the player getting possession of the ball, and it ends with the player distributing the ball or losing possession of the ball again. And all the events in between are marked by the same unique identifier. The same goes for team possession sequences. So all these player possession sequences are stitched to a bigger team possession sequence where all the events in between when the team first gets possession of the ball until it loses possession are marked again by the same identifier. So what this allows you to do then is you can then simply drill down into these specific sequences and look for like any type of sequence that you are interested in. For example, if you want to see sequences that ended in an attempt or kind of like where chances were created, you could look at them and you could see which players are most involved in these types of sequences, right? On more general, you could also just look at the average duration of a sequence, for example, to understand how long these sequences are. And kind of like an opposite of that, you can look at ball recovery time, which is basically the average duration of the opposing team's sequences and how long it takes your team to get back possession of the ball. And yeah, another step or another detail that we like to look at is positional context. So this is, again, very common. What you will see here that is done a lot is that the X and Y coordinates are added just to the on-the-ball event. So you would know, for example, where a pass happened and where the according reception happened. But you wouldn't really know what happened or what the other players did on that event specifically. So you don't have their positions because you only have the position of the event itself. So to tackle that, we kind of totally synchronize the events to the positional data. So every event is joined back to the closest frame. And this allows us to really have a wider look at what happened, and we understand what happened on the pitch during exactly that event and where all the other players were positioned, right? So on top of that, we then have a set of algorithms that we developed on top of the positional data that allows us to, when joined back to the events, really unlock some impactful insights. So a very common one is line breaks. So we have a units algorithm that kind of like groups these player positions into units, and you can see that here. And if that is then joined back to the event data, for example, to a pass, and you have the start and the end position of a pass, you would then know if if a line was broken by that pass and how it was broken. Was it like through, around, or over? And another example is offers in behind or in front of the opposition line. And also another example is the shapes. So we have a shapes algorithm. If that is then joined back to the receptions, you would know if a reception was made inside the opposition team shape or outside. Just to show you guys from the World Cup, from the last World Cup, how this was used, for example. So here you can see two of the metrics I just talked about and their impact during the World Cup. So our analysts were able to show that teams that created more chances of their receptions in behind and their defensive unit line breaks won their games more often during the World Cup. And yeah, this was made pretty easy because already the data is joined and it's just a simple query at your fingertips. So another lens we like to view our data through is game context. So what we do is that we have a phases of play algorithm that, again, takes the tracking data and batches them into a set of batches. These batches are then categorized or classified into phases of play. So here you can see kind of like an aggregated view over the whole game. And you can see there are different phases. So we have in-possession phases and out-of-possession phases. And here you can see the time the various teams spend in their various phases in respect to their in-possession and out-of-possession time. So as mentioned, this is kind of like an aggregated view over the whole match. But we really profit from a synergy effect here because already like mentioned before, the events are already synced to their closest frame. And every frame is part of a batch, which is then categorized as a phase. So we know directly in which phase a certain event happened, right? So this allows us to see, for example, how many attempts happened during a counterattack or were created from a counterattack. It also allows us to see if the ball was turned over, for example, during opposition buildups, or another example is just to look at pressures and when they were applied, for example, during high press, low press, or various block phases. Yeah, so again, just to showcase how this was used then during last year's Men's World Cup. So here you can see the impact of counterattacks during the last World Cup. And again, the main takeaway here is that teams that created more chances and ultimately more goals from their counters were more successful during the Men's World Cup. And again, this was made super easy because the data is already pre-joined and it's a matter of a simple select query. So yeah, this kind of like looks a little bit bad for you guys. I'm sorry, the resolution is a bit bad, but I will try to talk you through. So this is our data model. And what you should be able to see is that in the middle, there is our uniform event data or our FIFA football language event data. And then we have these context data sets that are linked it or kind of like live around it. So for example, on the top left, as mentioned before, we have the team sequences, and there you have like attributes like, okay, is this an attempt ending sequence, the duration of the sequence, the distance that was covered, the net distance, and these types of attributes. So what you could do then is that you select the types of sequences that you're interested in, and then you use this identifier I mentioned before to join it back to the events. And then you have all the different events on your fingertips with all the information about the players that were involved in those sequences. Very easy. Another example, or just another thing to note, is the positional context. So we again have two different ones on the right side. So on the bottom, you have the player positional context. And again, this is more or less like the raw positional data. So you have all the X and Ys for every frame for the players and the ball. We just add a few, I want to say, features on top. For example, we have the space around the player on that frame, the speed, and the movement direction. And this you could then add back to the events to know where all the players were during that event using the synced time step that I mentioned earlier. On the top of it, you then have the positional team context, which is also based on the raw tracking data, but we kind of like created this to have the information of all the units I mentioned earlier. So for all the different units, you would have information like the width and the height, and you would have information about the phases on that frame, so in possession and out of possession frame. So this you can then join back to the events using the sync timestamp again and the team ID to understand, for example, if there was a line break, why did that line break happen? Was it because the opposition unit was narrow during exactly that event? So it's very easy to make these kind of like insights, or to generate these kind of like insights. Yeah. So here, just a closer look behind the curtain on how we enrich the data. So this is our data enrichment process. Again, it doesn't come through very well here, but you could see it on the back on the other screens. Also, if you have more questions, don't hesitate to ask me afterwards. Happy to chat to you guys. So as I mentioned before, we have like two branches. We have the tracking enrichment and the event data enrichment. So you can see on the top, the tracking data hits our system. It then gets enriched first. We do the phases calculations, we do the units calculations, and we do sync it then in this step back to the event data after applying the sequencing. And then it's just a matter of creating these reports and data sets that we then push out to our member associations or to our teams that have qualified for the respective tournaments. And yeah, kind of like technology-wise, I mean, for you engineers out there, we are proponents of transient infrastructure, so we don't have infrastructure that lives throughout the day. It's just we kind of like scale it up when needed, and we scale it down again. It's just because FIFA, we don't have a tournament every other day, right? Yeah, and everything is fully containerized, so this helps with things like, for example, dependency management. So the dependencies of these containers or container tasks are completely isolated. Yeah, so just to show you guys how this, or the same paradigm then, powered the enhanced football intelligence metrics during the World Cup, for example, the Women's World Cup. So you might have seen some of this on TV, or if you were lucky enough and be in the stadiums, You might have seen the in-stadium graphics that were powered by the same paradigms. So actually, it's kind of like it's the same idea. It's just that everything is done in real time, which makes it a lot harder. But you can see that we have an event data stream and a tracking data stream. Those streams are then pushed into our Kafka. And then we have an algorithm called the data syncer, which again takes both the tracking data and the event data and syncs the data back in real time and creates these synced events. These synced events are then consumed by our EFI microservices, which then again push back these enhanced metrics. For example, you've seen things like here you have final thread entries or line breaks, but also there's other things like possession control and many more. So one thing that I want to also share with you guys here, I mentioned in the beginning that having a consistent historical data set is a great thing to have for a competition like, for an organization like FIFA. And here you can see how this is one use case of it. So on the very bottom, you can see that we do real-time benchmarking and ranking of all of our statistics. So during the game, if we see that a player, let's say she makes a great contribution to the game, and she surpasses some of our historic benchmarks that were built on previous tournaments, there is a direct notification in Kafka that goes to our match operators and to the commentators, which they then can use to make certain content decisions during the game. Yeah, and kind of like just to wrap it up very quick, just want to share with you things that we're looking to do in the future at FIFA. It's pretty similar to what I've seen already from StatsBomb. So we want to look at physical context and add physical context to our events, just to understand, for example, if there's certain events happening right after an effort or during an effort. We want to understand, or we want to make our data more understandable by using NLG to create text or natural language that is understandable by more fans, for example. And also, we want to look at limb tracking and ball tracking data, which we are lucky enough to have on our top-level competitions, and see what we can do with those two data sets. Yeah, thank you all. That's the end. Like I mentioned in the beginning, this is a link to the FIFA Training Center. And really, it's not only the FIFA football language that you can find there. There's also, we publish some of our reports for the senior competitions where you can find most of the metrics I just talked about. And yeah, have a look, and thank you all.
I did have a couple of questions, actually.
Sure.
What's the sort of latency on those? Like, it was quite noticeable, a lot of the stuff you talked about, I remembered seeing on the broadcast.
Yeah.
So.
It really depends on which metric. There are metrics that are solely based on tracking data. Those are basically live as soon as the frames hit us, so we don't add any latency on top of the tracking data. So if you use some of the tracking systems, they take, I think, 10 to 13 seconds to give you the scrubbed, or like, not the scrub, but kind of like the controlled frames, so it would be that. And then there's others that kind of like rely on event data. Those will take a little bit longer because you need to control the event data and you need to check if everything comes through correct. But the highest latency, I've done a lot of matches in stadium, and the highest I've seen is like for these event data statistics, like 20 to 30 seconds after the event happened, sitting in the stadium.
That's pretty fast. We have a question at the back. Oh, two questions. Go on, the chap next, Abby.
Yes, I was wondering, how many years back are you going, or is this just like a forward-looking?
No, good question. Actually, we do go years back. So for the senior men's competitions, we start at 2010. So we have the data back until 2010. That's when it kind of like ends, because if you go back, if you go further back, the video won't be good enough to do what we need to do. So basically, that's where it starts for the senior men's competitions.
Hi, thank you. For some data vendors, the timestamps for the events are not really accurate. So how do you deal with that and syncing with the tracking data?
Yeah, that's a very good question. So it really depends on which type of event you're looking at. So if it's a distribution event, it's easier to detect because you can rely on a certain set of physical rules. For example, the ball has to move away from the player for a certain amount of frames. So you could use that. For receptions is basically when the ball moves towards the player. So we have different set of rules for different set of events. But it really also depends on the quality of the event data, because I can tell you that for some event data, you won't get 100% sync rate, just to be quite open with you guys. But yeah, what you need to look at is like for most of the event providers, you can achieve like 95%. I think that is.
Yeah, in terms of like infrastructure, I saw that you guys have got Airflow and you're containerizing everything. Is that containerized on Kubernetes everything, or are some like managed solutions?
No, so everything is running on Kubernetes, like a hosted one, but I don't want to make any advertisement for our cloud providers. But yeah, no, everything runs on Kubernetes, and yeah, as I mentioned, it's just very helpful to be able to scale up the containers on scale, on demand.
If we could thank Sirus again, that'd be great.
Thank you, guys.